All right, welcome everyone to the Cleveland Our User Group. Today we're very delighted to have Meghan Harris, who is a data scientist at Memorial Sloan Kettering Cancer Center. Today she's going to tell us all about data validation with the Pointblank R package. So take it away, Meghan. Happy to have you here.
Happy to be here. Thank you. Let me share my screen. There we go. All right, can you see that? Good. All right. So, like he stated, my name is Meghan Harris, and I am here today to talk about exploring data validation with the Pointblank package. Now, just a little bit about me again. My name is Meghan Harris. I'm a data scientist. I work with Memorial Sloan Kettering Cancer Center, more specifically the Prostate Cancer Clinical Trials Consortium, or PCCTC for short. I've also just listed here some ways that you can contact me. I have my own personal website, thetidytracker.com, my Twitter handle, and LinkedIn. I will say that if you're trying to reach me super fast or need a direct answer or a question, Twitter might be your best bet. I will also give disclaimer. This is the part where I give my disclaimers depending on like what I'm talking about. So the disclaimer today, the disclaimer today is that one, I'm a little pregnant. So if there's something that doesn't sound like right, it is very possible that I got some brain fog. Again, I'm also not an expert in what I'm about to talk about today. And like, I'm pretty sure I'm going to have a slide for that saying that as well. So if at any point you're just like, that's not right, feel free to put in the chat, stop me, whatever. I will not get embarrassed. It's okay. I'm the first one to say like, I am not that smart. So it's okay. We're here to learn. It's all good. So what are we doing today? We're going to talk about what validation is and why we should care about it. We're going to just talk about some different types of validations as well. We're going to obviously talk about what the Pointblank package is. We'll talk about why we might consider using Pointblank over other methods or other packages. And finally, we'll talk about just some basic use cases. So again, here's my disclaimer slide. I am absolutely not an expert in data validation or the Pointblank package. So I'm very honored that I was asked to come and talk about it. I feel that, we really should have more diversity when we're having these talks and presentations, because it's not that we can just learn from experts. We can kind of put ourselves out there and just, corroborate together to see what we can come up with. But that being said, I am a great big pony. Okay, so like I said, if something does not sound right, or you know something that I don't, please share so that we can all learn and grow from the experience. So now, what is validation and why do we care? So really simply, validation is just the action of checking or proving the accuracy of something. That's pretty much it. And it can look like a lot of things though, right? So it can look like testing data inputs. It can look like testing data outputs. It could look like testing pipeline logic, or it could look like enforcing pipeline analysis or data rules. Of course, obviously, everything does not all the time fall into these four categories, but from my experience working, the last 5-6 years in this field, something kind of always just falls into these buckets for me. So, okay, that's what validation is, but why do we care? And I know that might sound crazy, depending on like where you are in your data analysis, data science, learning journey, field career, whatever you want to call it. But at one point, I really did not understand like how important it is. So why is it important? Well, if you guys were able to actually catch my RStudio conference talk this year, I did speak a little bit on this. And I did say that it was because if you do not check yourself, you will wreck yourself. And yes, I regret not thinking of making this picture to have in my slides at my conference, but they're here now. So that's all that matters. So if we don't have any kind of data validation, right, I like to argue the fact that your work is no good if it's not right. And I'll kind of like elaborate on this a little bit more. But incorrect assumptions about data can be costly and it can be unethical depending on like where you're working at. For me, I'm working with cancer research trials. If we get our point to a data where it's just out there and it's just wrong and we're relying on this for research purposes, that's unethical. If you're working, say, like in the more business side for profit marketing, and your analysis is wrong because, oh, like your data is wrong because you didn't validate it, that's costly. A lot of times we find out that real world data is usually complex and very nuanced. I don't know, like, first off, actually, I'm not formally trained, by the way. I'm not formally trained in data science. I kind of learned after I got my master's degree and realized that that was what I was passionate about. But I do hear stories about those that are like in school and doing courses and stuff, like when they switch and get a job in the real world, like whatever they had in school did not prepare them for the data that they see in the real world, which sucks and it's sad, but that's the reality. Also, external controls may be lacking or non-existent. And I mean this in a very broad sense. This could be that we have a lack of control or standardization with like our data collection processes, with anything internal before it gets to us or gets into our studio IDE. There's so many different levels of where something that you're not even expecting can just really have a trickle effect, like a butterfly effect on like the data that you're receiving. And it's really important to try to think about all of the different ways that that can affect you eventually as a data scientist or a data analyst working. But I like to argue the fact that when I say that, you know, your work is no good if it's not right, I want to emphasize the point that I'm not saying that like you have to be perfect, okay? So despite any kind of stereotypes and how awesome like our community is, how awesome we might think we are, data scientists, data analysts, professionals, whatever, we are not supercomputers. We are not robots. Believe it or not, we're humans, and humans are very prone to error. So the best way that we as data professionals can go about trying to put our best foot forward and trying to put our best ethical work forward is by kind of thinking about a systems approach of how we do our work. And one component of that is the act of adding validation. So it could look like, yeah, we're going to sit there and make up the best data validation plan and we're going to have all these strict controls or whatever. But 9 times out of 10, like, there's going to be something we didn't think about. That's just always what it is. And this is kind of why I say that the art of data validation is a rabbit hole, because all you need to hear is that one phrase, we should implement data validation. And I don't think you realize that by opening up that hole, the holes to the flaming pits of data validation, people don't understand what they can get themselves into, especially if you're coming into this as a beginner, like I was. So now that I've been trying to do data validation and I've been working in the real world for a few years, and I'm still not calling myself an expert at all, the only real solid piece of advice I can give for anybody who's about to like take the same leap or really starting to think about this seriously is do not fall for the validation prompts. Now, this is a term that I made it myself. I don't know if it's real anywhere. If I stole it from somewhere, I'm so sorry. But to me, what I'm saying is do not get caught up in the idea of making the perfect data validation plan because it doesn't exist. Right. It doesn't exist, okay? And I've fallen victim to this so many times because what ends up happening, at least for me personally, is I'll sit there and I'll be like, well, I can control for that, and I can control for that, and I can control for that. And I swear, if any of my coworkers were here right now, they would say like, yep, she does that. Because what ends up happening is that like I'll have these super complicated, probably like really logically awesome scripts that I rank in R, but like 9 times out of 10, like I'm trying to like over control for everything. And it's because I'm traumatized by the mistakes I've made in the past of things I didn't think about. So it's hard because there's this balance of like, okay, how much control do I give to my scripts, to my programs, to my pipeline without being over restrictive? And I don't have the perfect answer for that. Unfortunately, it's something that you kind of ebb and flow with and that you pick up as you get more experience. So like I said, data validation is a rabbit hole because you could probably spend an eternity thinking about your plans for validation. But if you decide to start thinking seriously about it, it's a very humbling experience and it should be done with care. Also, keep in mind that data validation plans should really be holistic and they should really have like a systems approach. And what I mean by that is that data validation is way more than just the coding that you're doing in RStudio. It is working and having conversations with other third parties, with stakeholders, with data management teams, data collection, understanding how the data is collected, etc. Right? So this is actually a lot of information here, but guys, let me tell you, the thing that like instills fear in my heart the most here is this last bullet point, because like I said, until you start getting out into the real world and working with other people, I think for those of us in this situation, we know how difficult this last bullet point is. We know how hard it is to work with other people who don't understand coding, who don't understand like these data concepts, even outside of validation. They don't understand why things have to be controlled in a certain way, whatever. So if you're going to be doing the same thing, kind of think a little bit more about that, kind of think about more of how you can incorporate all the other pieces that's going on outside of you and your department and your programs. So the one thing that I feel helped me kind of like move past this a little bit so that I can at least become functional and at least start like doing work instead of getting stuck in that validation crux was to start small. And what I mean by that is by looking at the data that you actually get in and just figuring out the minimum building blocks of logic or assumption that you might need. Only enough to make like a fairly confident guess that like, okay, this is probably accurate. But you also have to remember that it's normal for this to be an iterative process. It's normal for you for one day to be like, at the end of the day, you're just like, yep, all right, perfect, I got it. And then the next day, all of that gets burned down because you're wrong. Like, that's totally fine. That's totally fine. As long as like, you're not pushing anything like super serious, majorly out into production, like there should be like a lot of cycles of like back and forth, not only between you and yourself internally, but with other people about the validation plan and about the data, making sure that it means what it means or it means what you're interpreting it to mean, whatever. So, like I was saying, there's different types of validations that we can consider as building blocks to get started. And because I kind of want to frame this as like a beginner's really just dipping the toes kind of presentation, what I'll do is just go over some very basic different types of validations first before we jump into using the Pointblank package. So to me, I always list 8 basic types of validations. The list is not exhaustive at all, but these are just like the main types that I kept running into when I started out working in this type of work. So the first one I think is the one that people kind of think of the most when we think of data validation, a variable type. So basically, it's just like, is this variable the same class or the same type that we are expecting? So is R reading this example as a numeric value, an integer value, or is it just a string? I've had instances like that where, you know, I was a bad data professional and I didn't look at the data and I'm just like, oh yeah, that's a number, and not realizing that like, oh wait, that's not a number, it's a string. And I do want to iterate here that these are just really crude examples. Obviously, these are basic ways you can use base R to do kind of like light validation, but like these are not exhaustive. Please don't take this for what it's like. It's just an example just to kind of show what I'm talking about. We also can have allowed or expected values, and exactly what it sounds like is the value of the variable one that is allowed or expected? Can we confirm that the value R is reading makes sense given the context? So here we have a quick example. We have a value of age and a value of first name. So for age, we would expect it to be a valid number, and maybe we would expect the person to be born. So maybe it wouldn't be a negative number. It would be more than 0. So clearly we can see here that, yeah, if we're using some logic conditions to check that it's a number, that's not enough. We also need to check and make sure that the number is positive. And honestly, maybe that's not enough either, because maybe like we're doing a study that only has like adolescents or like the elderly or whatever. You can obviously add more onto this given the context. It's kind of like the point. It's just like, think about like, okay, it's more than just the data. Like, what's the context around all of this? And then obviously, like, you know, strings are hard. We're not getting into strings, okay? Like, strings are hard. If it's a name, we're expecting a string. Okay, that's all it is. Next, we could have missing data. So is there any missing data where there should or should not be? Sometimes missing data is not bad. Sometimes we expect missing data, or sometimes like it could be a good thing. But whatever the context is for your study, like make sure you make that connection. Do we logically expect any values to be missing? So here we have just a really quick data frame of like subject data, subject study ID, right? So in a clinical trial, if someone did not consent to getting, the study done and test done, whatever, maybe we don't put the subject ID in. Maybe we're expecting that to say NA or blank or whatever missing means. So just a really quick which statement, like, oh, like, is it where there's no ID value? Is the consent equals no? Something simple like that. Next, we can have logic checks. Now, can be used very broadly. So basically, like, is the data logically making sense upon delivery? Is it like working as we expected based on any kind of transformations we're doing, any kind of analysis processing? Does it make sense given the context? So the example here is like, we have old data and we have new data. One would think if we have new data, it's not the same as old data. Do not check your data frames like this. Okay, please don't. But to make the point, you can start with that basic building block of idea and then kind of flesh that out, obviously, to control more for it so that you're not like shooting yourself in the foot for later. Also, we have uniqueness. Should we expect data values to be unique or duplicated? Kind of the same as like that missing data. Just because we have duplicated data in some columns or some variables, it doesn't mean that it's wrong, but we should be aware of what it could mean. In this case, let's say that we have, again, that subject study data, and this is like a demographics table. So we can't have any kind of like duplicated subject IDs because they're only getting printed once. And here I'd be like, like we can use the base R function any duplicated, and we're making sure that value is 0, meaning that no, there is no duplicates. And if that equals 0, then that's true. Basic validation right there. We can also do string length. I actually had to work with this a lot in my last job. My last job, I worked as a data specialist working with opioid data and stuff like that. So there was a lot of geographic things. I cannot tell you how many times I've gotten zip code data. And, in the US, zip code data is supposed to consist of 5 numbers. And man, I'm going to tell you, there was really a time where I got 3 numbers and like they were legit serious that this was correct because, all of the zip codes in our area start with 14. So you should just know that this is 14142. How would I know that? Like, what? So I have seen some things and I'm traumatized, man. So just think about the context of what you're working with. Like if you got zip codes, like, and you're in the US, it should be 5, unless like you're doing little like fancy 4 things, whatever the situation is, just make sure. So this is a simple way that we can check for that. We can implement that into the workflow. Also formatting, is the general format of the data as we expect? And I feel like a lot of people run into this for the first time with dates and times. It was my example of dates and times, of course it was. So you would expect to have consistent date formatting, and we're not going to sit here and argue about which is right, okay? You notice like on my slide, my title slides, I always give 2 versions of the dates because I don't want people yelling at me that, I didn't put it in like the ISO, whatever, okay? So for whatever your context is, sometimes formatting is important. Sometimes it's not enough to just say, yeah, it's a string. No, sometimes we need to see like, is the date formatted how it should be? Is the time calculated properly? We're not getting into time because I don't need that headache, but for those of you who know, how traumatizing it is. And the last type of validation that I've ran into is range checks. So does the data fall into an accepted predetermined range? Can R confirm that, the data that we're getting matches the range that we're expecting? So for this, I don't like this example because I should have named this something different, because literally here in my comment, I'm just like, are all the subjects between the ages of 18 and 65 years old? So I really should have said over 18, under 65 or whatever. I should have like implied that 65 was also here in the logic. But again, this is a crude example, so please don't hate me. But basically what we're checking here is, okay, in our table, like is age more than or equal to 18, or is it less than or equal to 65? And we can see here that we can add a simple column. This is technically data validation of like, yeah, that's true here. No, that's false. These two rows here. So now that like I've gone over just really quickly, briefly, different types of basic validations, we can start to move into the point blank package. But to reiterate, my point here is to kind of get the gears turning. Your situation is going to be different depending on your work, depending on the data, depending on your organizational structure, depending on the data literacy of who you're working with. There's so many unknown factors. So what helps is to kind of have some kind of starting point, some kind of foundation based on the data that's coming into you. And then 9 times out of 10, you will have this iterative back and forth process, and you will feel like you're very not smart, but you are smart because you're thinking about this. So you're doing good. So, okay, now finally, we get to talking about point blank. So what is point blank? It's an R package, of course, by Rich Iannon, who's listed as the author and maintainer, and also Mauricio Vargas, who's listed as an author. And the package was created to assist with methodically validating data and keeping track of relevant metadata or data about data in R. So point blank has a lot going on with it, okay? And it wasn't until like I started trying to make these slides that I was getting scared. I was like, and this is supposed to be a beginner, like, I don't know. So my awesome solution was to not show the whole package. 1, because I was concerned for time, but 2, because I really wanted to present this in a beginner's lens. I wanted to be that if you've never done data validation before, you could literally just follow this and just start doing something, because I'm right there with you, okay? So Pointblank actually has 6 presented validation workflows in the package. And they're very like comprehensive. All of these links are active. So if you have the repository, you can click on it, you can go through and read them in depth at your own leisure. But for the purpose of this presentation, I'm only going to focus on workflows 1, 2, and 5. So we'll start with the data quality reporting, move into the pipeline data validation, and then move into the table scan. But before we actually get into the nitty gritty of that, because this is getting to use cases, we'll talk about why we might consider using point blank. I mean, obviously we can do data validation with base R. You could do anything with base R probably. I mean, it might not be easy, but you could do it. There's other packages as well. But why would we want to use point blank? So like I was saying, while you can use base R and other packages like validate or test stat, point blank is different in that there's a really heavy focus on implementing easy reporting and a methodological validation schema with ease. And why we might prefer this, especially as beginners, is because the package allows us to kind of focus more on the other things that we want to do, right? So if our point of trying to validate data is to literally just get a quick report out to somebody else, where we don't care about what it looks like, we just need a quick, clean report that makes sense and is easily readable, point blank is your package. If we already have existing workflows, we've already put a lot of time into like other reports that we might have. Maybe we had all of our stuff in R Markdown and we switched it to Quarto or like whatever, we have existing stuff. Point blank is perfect for that because you don't have to use its reporting functions, as we'll see when we get into the second workflow that we'll look at. Also, if you're super lazy, I mean, because hey, sometimes you get super lazy and like maybe you want to just literally have a function where you just look at the data for what it is, and we don't do anything with validation. We just get an idea of what we're working with, and then we call it quits for the day. Point blank's got you covered too. So I thought it'd be a really good package to kind of ease into as beginners to validation. But like I said, to a lowly beginner like myself, point blank can be very overwhelming, guys. Because look at this. These are all of the functions that are in the package, and we're not going through all of them. This is a lot. I put this here because I just really wanted to drive the point home that this package is a lot. So while I'm only going to really scratch the surface, if you are already to the point where you far surpassed me, please use like the reference links and everything to get yourself to whatever level you need to read at, because this was a lot to me and this almost like terrified me to not use it. But my hope is that after I show you some quick things, you'd be like, oh yeah, I could use that real quick. But like, you know, don't feel bad about ignoring everything else. So Now that we know what it is, why we might consider using it, let's just get into some use cases. So that first workflow that I said we would go over is data quality reporting. So pretty much, very simply, what happens with this workflow is that you start with a table, a data frame, a tibble. If you're really super fancy and using like the Spark, what is it, Sparkler? I don't know, like big data, whatever big data, like the Spark package or whatever, you can use that too. I'm not that fancy. If you are, kudos to you. So you start with a data frame, tibble, some source of data, and then you use something called an agent. Now, this is just a fancy word for function. He just named it agent, okay? So you use a function and you give that function some validation rules, which are also more functions, okay? You just use some functions on the table. And then lastly, you use another function called interrogate to interrogate the table. So we're using this one intermediate function to kind of like get us information about our data frame, our tibble, or whatever. And honestly, I just want to say I love this because not that it took me a long time to realize, but like my brain is like moving slower. I'm just like, oh, all of this is like spy themed. And like, that's brilliant because I mean, as trying to do data validation, it really requires this kind of like investigative eye. So I kind of get where he was going with this because it's like you're telling these other functions to kind of do your dirty work for you. It's kind of like awesome, brilliant, in my opinion. So let's just do an example scenario, right? Because I'm like, oh yeah, we just use an agent and whatever. Like, no, we have to like see this actually working to like, at least for me, I have to see it working. So I made an example scenario. So we've got just some aggregate study data. It includes a total number of patients present in a US clinical trial. Each total has an associated report date that's recorded. And because this is the real world, there's like no external control in the collection process and it's F tier. Like this is terrible data, guys, but that's what we want. So for those of you that brought down the repository, you're like working along with this. This is actually in the directory in the example scripts folder, example script -1. So first, what we would do is load in our data, however way you want to do it. I use a tidyverse, so I'm using the reader package. Get the data in, and we can view it or we cannot, right? Remember how I said Pointblank lets us be lazy? Like we totally could not view the data if we don't want to, like, but we should probably. So we literally only have like 5 states. And you could probably see there's lots of like inconsistencies and errors and everything here, and that is on purpose. But we can see we have our states, the total patients, and the report date. So just kind of looking at it a little more cleanly, this is the data we have. So the validation process starts with you not like doing anything in R, okay? And I mentioned this in my other talk, like the first thing you need to do is not touch R because you need to understand what's going on. You need to make a plan based on the data that you have. So we can look at this table and be like, all right, let's just make some observations, right? There's 3 variables, there's columns, 5 observations, 5 rows. We have a state variable. So looking at this, I'm like, okay, this is supposed to be official US states. We'd expect it to be spelled properly and capitalized maybe. We have a total patients, so we'd expect this to be a number. We'd also expect this to be a positive value because it's a total aggregate number. It's not like a change in anything like that. We'd also expect a reported date of entry. So we'd expect it to be either a character string or a date format, but we'd also expect it to be consistent formatting for all the observations. So if we're going to use a Pointblank package to kind of like tackle this, how do we do this, right? So first install and load the Pointblank package. But remember how I said like, okay, we're going to make an agent, right? We're going to use an agent function. So there's a function called create agent in the Pointblank package. And it can take 2 arguments. So it's TBL for table. So, okay, like this is our example data that we had loaded in. And also you can name that, and that's just for human readable, you know, for reporting and stuff. Like I don't think you technically need to have the table name argument in there, but we're gonna just put it there for those reasons. So the next thing we'll do after we go ahead and use the create agent function, we'd actually need to pipe in some validation rules. So I actually meant to reach out to Rich about this because I tried to actually use the native pipe here and the native pipe was giving me errors. So I'm not sure if he hasn't updated that yet or if I'm just dumb. I don't know. McRitter's pipe was working for me. So now the cool thing is though, you don't have to load dplyr or magrittr or whatever to get it. Like he did put the pipe like in the package. So you can go ahead and just use that as is if you're really trying to limit the amount of packages that you're using. But anyway, so you have to pipe in your validation rules. Now here on this slide, I did go ahead and put in a link at the validations rule right there on line 2, because it'll take you to like all of the different options of different validations that you can do, because we're only going to use these here for this example for the presentation. So now knowing that, like, okay, we can put in our rules, knowing that we have these little intricacies of like our state, our total patients, report date, whatever, we now will tell the agent what exactly we want it to do. So first, we're just like, okay, we want to make sure that there's only valid states in the column, for states. So there is a function called column values and state, column values and set, sorry. And the first argument will be whatever column that we want to address. And the second argument will be like a reference. So right now in this example on line 6, I'm using the R base constant state.name. If you put in state.name into your console, it'll actually give you a list of the 50 states if you didn't know that. That is a cool way for you to check if you have correctly spelled and capitalized states if you're ever working with this type of data. Next, we're looking at the total patients column. I'm like, okay, like I need that to be a number. I didn't do anything else there, but of course, remember I said that we're doing total aggregate, so we don't want any negative numbers. So we can use col_vals GTE, which is greater than or equal to. So do we only have values that are greater than or equal to 0 in the column? And then lastly, you just say column is date, so is the column type of date. So after we go ahead and pipe in all of those validation rules, you can see that we actually piped it into an object on line 4 called patient agent. The last thing that you need to do is use the interrogate function. So when you do that, it will actually move yourself over to wherever your viewer pane is in the IDE, and it will print out this really nice looking like table. It's kind of fancy. It's kind of fancy. So what it does is like, it's literally doing everything that you said, and it's just giving you a summary of like what happened when you typed it into the console. So I thought it'd be helpful to kind of like just break this down, because some of these things don't look as they should because we didn't add certain objects because we're beginners. We're not getting fancy, but let's just go over it real quick. So looking at it, first we have some date, time, object metadata. So when did you run it? What day did you run it on? How long did it take? Stuff like that. Next, we have the step column. So this is pretty much listing every validation rule that you gave to the agent to do. And if you notice here on the side, we have these little like green tab thingies. So if it's green in general, regardless of if it's like this lighter green or darker green, it's just letting you know like, hey, like we were able to actually like try to implement this or check this without any like actual like syntax issues, like this ran for you. But if you have a lighter green, that means that something failed, like it found something that should be failing the validation, like something's not right in your data based on the information that you gave it. If you have this darker green, that means that it did successfully pass your validation. So that is probably what you're expecting if your rules are correct. Next, we have the columns list. This is literally just your variables that you have. Inside was there a question? No? I'm sorry, I thought I heard. Okay, sorry. Just want to make sure. Because like I said, if you have questions, like stop me, like it's okay.
Megan, I'll ask a quick question for you.
Yeah.
That call-val, the GTE, the greater than or equal to,
Yep.
What happens if like one of the values is missing there? How does it evaluate? What is it, can it?
Ooh, that's a good question. I don't know. So
Yeah.
I would like to think that because it can't say that it's the actual value, I'd like to hope it would fail it. Because I don't believe there is an option for like removing NA like we have for some of our base functions. That's actually a really good question. Oh, well, I purposely did not want to do like an actual in live review of this because I didn't want my computer to die. I didn't want my computer to die. But yeah, that's a really good question. I would like to hope it would fail it. I would like to hope it would fail it.
I'll check it out.
Yeah, no, thank you for asking that. That's a really good question. But yeah, so columns, just our variables that was in a data frame, and our values. So these are the values that were used to check the validation. So not necessarily the values that were present, but just like, okay, what was used? Because like I said, right, I don't remember the states I had, but I know I definitely did not put Alabama or Alaska. This is just showing like, hey, we used that state, that name's constant. We use this to check for your validation. Next, we have two kind of columns together, like table and evaluation. Pretty much, this is getting a little bit more complicated, and I'm not going to get into for this because this is a beginner level, but there are ways that you can add kind of like these transformations, these mutations before your validation steps are ran. So this would change if there was any kind of changes to this. And this is just to ensure that you have the integrity of the data that you put in. Eval is just another way to make sure, like, did R run into any problems? Was there any issues with syntax? Was there any errors or warnings that came up in the background that would affect how this is being viewed right now? We also have the units column. So this is pretty much like, okay, what was the total number of steps or a total number of like tests that was given in each step? And like this one is just like a very generic one. I don't feel like our units or pass fail values are going to change that much with this example. One, because we're only using like 5 data points, and like 2 because we're not getting too into the weeds with arguments and things like that. But pretty much the more you kind of learn the point blank package, you have a lot more control over like how you're testing. And we'll go a little bit into that, but we're really not gonna, get too much into it. So we're seeing here 5 units because, oh, it's checking each row and we have 5 rows. We're seeing 1 unit here because, oh, we were just checking an entire column just to make sure that column was numeric and nothing else. That's why that's that way. And that's just what I said. Yeah, so 5 because we have 5 rows of data, 1 column because we got 1. We also have pass fail. So this lets us know just, okay, how many of your tests pass, how many of them fail. And underneath it's supposed to be an accurate like number, percentage, fraction of like the unit testing and stuff. But because we're not getting into the weeds of that, I believe all these examples are just showing 0 to 1. So when you go and like actually go back to the point blank package and start doing more advanced stuff, you can parse this out so that you're getting actual full-on percentages, if that's going to be helpful for the type of work that you're doing. We have this WSN column, and this is for warning, stops, or notifications or notes. And this is empty because we didn't set something called action levels, which we will get into after we talk about data extracts, which is the next column here. So if you're doing this in your IDE and this pops up in your viewer pane, these are actually clickable hyperlinks. And what they'll do is if you had any data that failed your validation tests, it will literally export it out for you into, I believe, a CSV, right into your directory. So that's awesome. Like if you just really quick and dirty need to like show someone what they did wrong or something like that, you're just like, here, this is what needs to be fixed, or this is what's failing my validation, like go spell this state correctly, or go fix this, or whatever, check into this. That's really useful for that. But sometimes, I mean, maybe you just want to work with a data extract without it getting like pushed out into a directory. So we can also, like, if we're going to go ahead and use this workflow so that we can see like our pretty little viewer interrogation pane, we can also add on get data extracts, which is in the point blank package as well. And because I'm just really picky about like how stuff looks, like I'm setting my names for things. You don't have to do this part. It's just because if we didn't do this, it would literally just be like 1 and 2, because what it ends up doing is it gives you a list of pretty much your data that had failed your validations. So looking at it here, I have 2 things that failed here for state because Maine is spelled wrong. And Pennsylvania is spelled wrong too. You know, I hate Pennsylvania. I mean, I don't hate Pennsylvania. Like, I never know how to spell it because that wasn't supposed to be there. Like, that was supposed to be spelled right. This is not smart. And then for our patient total validation, we failed this here because it's not greater than 0. So it'll literally just pull it out for you. Just be like, here's where it's messed up. Go fix this. So now that we've done that, I did say we would talk about action levels really quick, and I'm not going to try to breeze too much over it, but I don't want to confuse people. But pretty much action levels is a way to give more directives when interrogating our data, because maybe we want it to be that, like, if we got 50% of the data that's coming in incorrect, we don't even want to bother with it. Like, we just want to like yell at whoever gave it to us and like not give ourselves a headache. Or maybe something else. There might be other reasons why we want to have these different percentages of like thresholds. But the way that we would do this is using a function called action levels. And there's 3 arguments that we can put into action levels. We can do warn at, stop at, or notify at. So we can say like, okay, if 20% or 0.2 threshold, whatever, is failing, give us a warning in the console, but still run it. We can say that if at least 50% of that data is like failing, like just completely stop the script. Like we're burning this down. Don't even do it. Don't even do it, okay? If we wanted to be that like anything at all, so like anything happens at all, just like tell us, notify us. That's where we'd put that that number 1 there. So when you do that, you store this into an object, because action levels will make like this kind of like, I don't even know what the like the actual like object type is. I think Rich describes it as just an action levels object. So we're just going to call it an action levels object. So I'm putting it into an object called AL. And what you would do is like, you would just take that existing code that we had and literally just add another argument into your create agent. And what this will do is implement all of this. So when we go ahead and rerun it to reinterrogate it, now it looks a little different, because now we're saying like, yeah, like if we had these issues, like flag this, like don't just leave it alone. So pretty much it looks almost identical, except now we got some more colors. We have like, okay, yeah, you told us to warn, like if it's 20% failing, stop it if it's 50% failing, notify if like anything happens at all. And it correlates as well to our WSN columns here, because we can see, if you see right here, the only one that's green that had no issues with it at all was just checking that total patients was numeric. And we can see all of these circles are just open, you know, because this ran perfectly. But if you have any issues, obviously like anything that was failing at more than 50%, you have your red tabs. Anything where you said to warn will have your yellow tabs. You can still pull out your extracts. But if it's filled in, obviously it's just like, we got the flag to notify you, we got the flag to stop, we got the flag to warn. I haven't used this yet, but you know, if you're at that point where you're at that level where you need this kind of precision, action levels is your way to go if you want to do it this way. Okay, so is there any questions about data quality reporting before I move on to the next use case? No, we're good. Okay. Okay, so what if we don't care about reporting? What if we already got like these crazy pipelines already and we already got our own reports? We don't need that. So if you don't need any of that, this section is for you. So the second workflow is pipeline data validation. So it's similar to the other method, right? So we would start with a table, a data frame, and table. But now this time what we're going to do is, instead of using this intermediate function of like agent and interrogating and all that stuff, we're literally just going to take the validation rules and just strictly put it on the table. And what this is going to do is give a report of any kind of side effects or findings like straight to the console. And this works this way so that you can integrate these functions into your existing pipelines. So you already got objects, you already got like your own stuff set up. This is a way for you to just add an extra level of validation protection into whatever you got going on already. And I'll show you what I mean by that. So this time, let's say, okay, we got that example data. We want to do the exact same validations, but we don't need a fancy R markdown table. Okay, we just need our results, right? So you literally could just use the same validation rules we did. And if we wanted to say like add our actions to warn us or stop on fail or whatever, we just put them into each different validation rule depending on what it is. And this is honestly like, you might prefer this if you want more control based on like what exact like point you want to be warned at or stopped at. It really just depends on your situation. So you can use the function warn and fail for targeted warnings. You can use stop on fail for, stopping. And you could also, like, if you just want to be lazy and you don't care, you just want to throw all the action levels in again, you could just use the action level objects as well. But if you're super lazy, you can do no actions at all. You can just do a basic test. Like, is it a date? Like, is it this? Like, we don't have to get fancy here. So what's cool about this though, is that if we do it this way without doing the interrogation, the agent, whatever, what ends up happening now is that if you have anything that's triggering your validation rules and it's failing at a certain point, whatever, it will halt your workflow down. So if we were to run this, it'll just give a straight error. So what is cool about this though is that if we change this around, say, because that only validation rule that we had that passed was that the column was numeric for total patients. If you go ahead and put this into your console or into your script, you will literally get a printout of the tibble. And this is just what happens in a normal workflow. So you have allowed yourself to test and make sure that the data was as you were expecting, but now you literally can just go ahead and do whatever you're doing. You want to put this into an object, you want to put it into Pardo, you want to do whatever, like it's just seamless. So this can be extremely helpful if you already got your validation, your workflow set up and you're now thinking about like I should be adding some validations. This allows you to maintain your workflow and just pull out the side effects or only stop it when there's an issue that you've put it. And I do want to say, be careful about that though, because if you're not thinking about all the different things that can happen and it passed. So like in this example, right? Like if this was my only validation rule and I'm just like, yeah, all that data is fine. It's not fine. It's not fine. So be careful. If you do it this way, be careful. Because Crystal, you're laughing. It's the truth, okay? It's the truth. But it's a really cool way for if you're kind of like a little bit more seasoned and you're like, okay, I know what I need, or at least I have an ideal idea of what I need. I already got all these workflows in place. I'm not burning this down. I'm not making reports that I have already built them. This is your way to go. Is there any questions about the data validation at all? Because that's literally it. And I love that it's that simple because it really just allows you to mold it into whatever you need based on whatever you got going on. So if there's no questions, we can actually get to the last use case. I was going faster than this than I thought. So the last use case that I'm just going to present on today, this is a lazy man's, lazy woman's, lazy person's, whatever, lazy person's way to go. So if you just want to find out what kind of data you have, you can use a table scan. So there is a function called scan data, and all you have to do is just pipe it and just use it, and that's it. And what ends up happening is that you'll get an HTML output. So I'll go ahead and click through here. So if we run that function on this data set, we get a lot of information here. You'll see we have a lot of different tabs. This is all just the information that's on here. But what it'll do is it'll give you an overview. So how many columns we have, are there any missing character, numeric column types, things like that, duplicate rows. Then we'll also see variables. So like, what variables we got state for character, numeric, things like that. And then more like if there's able to do like any kind of calculations on things, it will try to do that as well. And we can also get really fancy and look at like interactions and different stuff like that. I don't feel like any of this like applies too much, but it's here if you have data that does that. You get super fancy and get into like correlations, missing values, different things like that. This kind of reminds me of the what is it, the Data Explorer package that kind of does this, gives you like a generated like RMD of your stuff. You can also get some reproducibility information if you're debugging or got to go over to Stack Overflow. God bless you if you do, if you have the bravery for that. So you have your version stuff here, more of that metadata. But that's pretty much it. Like, and honestly, like I kind of argue like we kind of should have did this first, right? Like I was just like, why didn't he like put this as workflow 1? Because I feel like that's the #1 rule of like when you're working with data, like you have to like know what you're getting. But because like I'm a stickler for like order, I just followed the order you went into. But this is probably the first thing you should be doing. But yeah, so honestly, that's it for that. And I mean, you can also add in like these different options, right? So we have these different arguments here. And if any of you ever worked with, what package is that? Is it the data DT package where we're like doing like, what is it? Is it JavaScript? I don't remember. There's something with that package where like, it's like, oh, you put in a character string and it like, you can tell it which components of your table that you want. It's the same thing here. So if you want your overview, if you want the variables, interactions, like you can put that in there. If you want that navigation bar on or off, it's there. You can actually also use the lang argument to give a different language. So if you're presenting to something in another language, you're bilingual, whatever, you can switch it to these available languages here. Also, for some reason, there's just a random width option. If you thought it was too fat, you can make it smaller. Hey, whatever. And locale as well. So if you have any reports or whatever that have to go out to certain countries that they format their numbers differently, you can. So I did do like a really quick example of this. I'm just like, okay, I just want OV, which is overview and variables. I don't want a navigation bar. I'm going to rep my half Puerto Rican side and say like, we're going to get some stuff in Spanish. And I want it to only be like 500 pixels and like change my numbers for Spanish countries, right? So when we do that, you can see that it does it seamlessly. I mean, obviously your stuff that you put in, that doesn't get automatically translated to you. It's not smart enough for that. It's okay. That's fine. We still love it. But you can see I only have the overview section here and the variable section here, literally nothing else, no nav bar. Same thing with reproducibility. It's just a really quick and dirty way to just get information about your data. And I believe that's it. I got through that a lot faster than I thought I was going to. So is there any questions about anything at all?
That was great, Megan. Thanks so much for a very good talk. I think what you said in the beginning was really important, that we don't want just expert talks, right? Because experts forget how it is to learn the talk, right? So saying, I just did this, it's fresh in my mind, and this is what I found confusing. Because anyone else who's going to start trying to do it is going to be at you at that level and not at the expert level when they start. So that's, I think it's great.
I don't know. I mean, I know some idea of what I'm doing, but I don't know.
Oh, clearly you do. Yes, clearly you're being humble, but no, it was great. I'll kick off the questions with, so if you work like in a group, how do you have a single script where you all contribute to the validation? Like, how do you prevent everyone from doing this themselves, like reinventing the wheel, right? If your analysis group gets a new data set, does one person get tasked with doing all the validation? Did everyone try to do it themselves, or do you have a central place, like, let's all come together and how we want to validate this?
Right. So I love this question because at my current job, right, I've only been working there for about 5 months, right? I'm only working there about 5 months. I'm about to go on maternity leave. It's gonna be fun. So, but what ends up happening there is that we heavily use Git, obviously, for version control, Git and GitHub. And what it'll be is that, yeah, we will, divvy up work for things, but we all will go through a review process based on like a hierarchy of who's been there longer, like who knows what. So I just got done with something where I just kind of took a stab in the dark, and just because I believe our department has only been like operational for about 2 years, the data science department where I'm at. So we're still in that process of making SOPs, like getting all this together, making validation scripts. That's actually a lot of what I'm going to be doing when I come back from maternity leave, actually. So my hope is to get centralized scripts where like, yeah, we'll have, especially if we have like separate, like similar data across like different clinical studies, we'll have a really, I don't want to say generic, but like a more broad process that all the data will run through first. But for that process of actually creating that script and everything, that's going to involve a lot of people. That's going to involve everyone in our data science department. We have a data management team as well that does more of the actual pulling and extracting of the data, the SQL type stuff. That's even going to involve working with the clinical, like principal investigators and researchers on the clinical side as well, to make sure that we are interpreting those validations properly. So I can already like see it's going to be a very, inclusive process, which it should be. It should be, because it really should not be that like only one person is doing validation. Like, and I think that was kind of the point I wanted to iterate about us not being robots, right? Because I'll be like, listen, I probably messed this up. I was probably coding at like 5 a.m. and I don't remember what I did, and this makes no sense, and I'm sorry. Like, I've said that many times. So if you naturally just have more people on, more eyes on it and more logical brains on it, like it might be that someone interprets something differently, but you can get to a consensus of what would be most appropriate for the situation. Yeah.
Great, thanks. I'll let someone else jump in.
That or not, we can just, it's fine.
Well, I do have another question. So while people figure out what they want to ask. So you showed us multiple like kind of interactive HTML documents, which are really nice. But let's say you're scripting this, you're scripting a bunch of different data sets. Is it easy to save those HTML documents to a file so that you can come back the next day and say, okay, here's my 10 files, open them up and look at it?
So if I wasn't afraid of my computer breaking, I would have just shown that. So it does automatically save everything into your directory. So it's there for you. Yeah. Yep, it's there for you as an HTML document.
I'm just looking through the chat. Yeah, but
No,
did you
it's
see
fine.
the chat? The comment someone said,
Oh no, I
you should have
didn't.
seen about 3 years ago, Toyanola. So better late than never, right?
Yeah. Oh, thank you, Brian. Yeah, no, totally. I mean, 3 years ago, I didn't know what data validation was. So thank you, Crystal. I'll see you later. So yeah.
All right, so no more questions. Thanks again, Megan. Welcome back anytime. Obviously no time soon. Enjoy your maternity leave.
I'm gonna go have a baby.
So thanks again. I hope to see everyone at later events. Bye, everybody.
Thank
Have a good
you.
evening.
Bye.